In the next 72 hours, the average American household stands to lose between $400 and $900 in perishable assets. It isn't because of a natural disaster or a war. It's because our entire food security system is tethered to a single fragile wire. We have been conditioned to believe that cold is a commodity, something generated by a compressor fueled by a utility company and housed in a white plastic box with a planned obsolescence of 10 years. But for centuries, the spring houses of Pennsylvania and the root cellars of the Midwest maintained a perfect, constant temperature without a single moving part. It is 100 degrees outside, the humidity is crushing. And yet this is at 40 degrees. Today, I'm going to show you the Lithic Heat Sink, the Lancaster Creek bed secret that the $100 billion appliance industry has spent a century making sure you forget. We are going to discuss the geothermal constant, the Bernoulli bypass, and how a specific type of riverstone found in almost every North American creek can become your new zero-cost power plant. To understand why we don't use this today, we have to look at the economics of dependency. In the early 20th century, we didn't just invent refrigerators, we invented a business cycle. A refrigerator is an active machine. It fights the laws of thermodynamics every second it is plugged in. It uses high-pressure chemical refrigerants, HFCs, that have a global warming potential 1,000 times greater than CO2. These machines heat up your kitchen to keep your milk cold, which makes you run your AC harder, which increases your electric bill. It is a closed loop of consumption. The springhouse technology used by the Amish and early settlers was a threat to this model. Why? Because it's passive. It relies on the thermal inertia of the Earth itself. The industry didn't ban these methods, they simply designed them out of the modern suburban lot. They shrunk our yards, removed our access to groundwater, and made home improvement synonymous with buying a new unit. Today we are reclaiming that knowledge. Let's talk numbers. This is where the authority of the secret lies. If you dig 6 feet into the Earth anywhere in the temperate world, you hit the geothermal constant. In the United States, that temperature is roughly 55 degrees Fahrenheit. This is the baseline. For thousands of years, humans used this for cellars. But 55 degrees is not a refrigerator. It's a cool room. It's great for potatoes, but it's a death sentence for raw milk or meat. To get to 40 degrees, the safe zone, you need to break the 55-degree floor. The Lancaster secret uses 2 principles of physics that your science teacher likely skipped: specific heat capacity and the lithic heat sink. Certain stones, specifically limestone and sandstone, have a unique thermal profile. Limestone is roughly 40% calcium carbonate. It has a high thermal mass, meaning it can store cold, but it is also porous. This porosity allows for microcapillary wicking. When these stones are submerged in a flowing creek or placed in damp earth, they don't just get cold, they become a thermal anchor. The heat transfer equation for our system looks like this. Q is the heat flow, K is the thermal conductivity of our creek stone, A is the surface area of our cooling chamber, delta T is the difference between the blistering 100-degree air and the 55-degree ground. By manipulating the conductivity, K, using the Lancaster stones, we can accelerate the removal of heat from the chamber at a rate that a standard dirt hole simply cannot match. Here is the part that moves this from a basement to a H-fridge. In Lancaster County, the most effective systems aren't just buried, they are the water-jacketed. If you have a moving water source, a creek, a spring, or even a slow drip well, you can use the Bernoulli principle. As water flows, it creates a slight pressure differential. By wrapping your cooling chamber in a jacket of crushed creek stones and allowing a small, constant trickle of water to pass through those stones, you trigger continuous evaporative subcooling. The water seeps into the pores of the limestone. As the ground air passes over the stones, it evaporates that moisture. Because the stones have such high surface area, the evaporation is massive. This process steals an additional 10 to 15 degrees of heat from the interior of the box. 55 degrees minus a 15-degree evaporative drop equals 40 degrees. You have reached the safe zone. No compressor, no Freon, just the energy of moving water and the geometry of stone. You can build a ancient proof of concept version of this for less than $20 in an afternoon. Step 1. The site selection. You need a spot that is geologically damp. Look for where the moss grows. If you have a creek, stay within 10 feet of the bank. If you don't, you'll need to provide a 8-drip source. Step 2. The M-bar lithicum footing. Dig a hole 4 feet deep. At the bottom, place 6 inches of large, unsmooth creek stones. These stones act as the feet of your system, pulling the deep earth cold upward. Step 3. The double wall chamber. Place a 5-gallon bucket inside a 10-gallon bucket. Fill the 2-inch gap between them with crushed limestone or sandstone. This is your jacket. Step 4. The chimney. Run a 2-inch PVC pipe from the stone layer to the surface, angled away from the sun. This creates a passive draft. Cold air is denser than warm air. It wants to sink. By providing a chimney, you allow the warm air inside to be pushed out by the heavy, cold air from the stones. Step 5. The hydration. Keep the melt jacket stones damp. If they dry out, the system reverts to 55 degrees. If they stay wet, the temperature will plummet. Why does this matter beyond a cool DIY project? We are entering an era of energy volatility. As global oil supplies tighten and the micro-impact of geopolitical crises hits our utility bills, the most radical thing you can do is decrease your surface area of vulnerability. Every watt of electricity you don't need is a watt you don't have to work for. The Amish aren't anti-technology. They are anti-dependency. They look at a refrigerator and see a chain. They look at a creek bed and see a resource. When you build a lithic heat sink, you are reclaiming a 7,000-year-old engineering heritage. You are opting out of the $130 billion cycle of non-manufactured heat. I'm not asking you to take my word for it. I'm asking you to check the physics. This weekend, I want you to go to your local creek, find the limestone, build a test sink. Post your data in the comments below. I want to see your depth, your stone type, and your final temp. We are building a public, open-source map of the Earth's cooling potential. If we can prove that 1,000 people can keep milk at 40 degrees for free, the appliance model starts to look very different. And in the next video, I'm going to show you the gravity-fed light. It's a 19th century Lancaster secret that powers an LED for 4 hours with 0 batteries. The grid is a choice. Subscribe if you're ready to opt out. I want to see your results this weekend. Let's reclaim the secret together.